We will now move on to number 26. Number 26 gives us a piecewise function and it wants to know which one best describe the function. So we first check for continuous. The function is continuous if it takes on the same value at x equals to 0, if these two p's takes on the same value. So we call this the first piece and the second piece. Let's go ahead and plug 0 into the first piece. You get -1. Let's go ahead and plug 0 into the second piece. You also get -1. So it passed the continuity test. Let's check for, just check and see if it's differentiable everywhere. So we take its derivative. The derivative of the first piece is going to be 1 plus sine of x. The derivative of the second piece is going to be 2x plus 1. And we're going to check for continuity. We're going to check for differentiability at 0 as well. So differentiability at x equals to 0. So we also plug in 0 for the first piece and 0 for the second piece. For the first piece, when you do plug in 0, then you get 1. So the derivative at 0 is 1 for the first piece. And the derivative is also equal to 1 for the second piece. So it is differentiable at 0. Therefore, this function is both continuous and differentiable because they both pass. They both equal to each other. So we would go here and we would choose option A because option A says continuous and differentiable. All right, number 27. Let f be a polynomial such that, so we know that f of 3 equals to 3, f prime at 3 is 0, and then f triple prime at 3 equals to -3. What is the point 33? Point 33 on the graph. What is it? Okay. So the fact that I know that the first derivative at 3 is 0, then I know that that's a critical point. So x equals to 3 is a critical point. That means that it could be a maximum, this could be a maximum, or it could be a minimum value. Now we also take a look at the second derivative at 3, and it happens to be negative. So since f double prime at the critical point is negative, it implies that the graph is concaving down, and therefore that's a local max. So 3 is actually a local max. So relative max, relative min, it's a relative max. So we choose option A. Okay. All right. Problem number 28. Given that the function 4 plus 3 over x, find all the values c between the interval 1 and 3 that satisfies the mean value theorem. Satisfy the mean value theorem, okay? So if you recall what the mean value theorem says, it says that there is some point C such that the derivative at that point equals to the value equal to the average value in the function at the endpoint. So you basically plug 3 in there, plug 1 in there. That's how you find the change in the y. And then you subtract. That's how you find the change in the x. So the derivative at some point is equal to the average rate of change, or you can think of it as the slope. So first we need to know what f of 3 is. F at 3, if you plug 3 in here, you have a total of 5, because 3 divided by 3 is 1, plus 4 is 5. If you plug 1 in here, you actually get 7. So then the derivative at some point equals to negative 2 over 2. So negative 2 over 2. So the derivative at some point equals to negative 1, because that's what it is. All right. Now, what is that point? That point has to be between 1 and 3. Where is between 1 and 3 such that the derivative equals to negative 1? So we begin by taking the derivative of our original function. And by the way, this is the definition of mean value theorem. So far, we have just translated what it means by the mean value theorem. Okay. Now we're going to go ahead and find the c value. And we begin that process by taking the first derivative of the given function. That's the given function. And the first derivative of the given function is going to be negative 3 over x squared. Okay. So go back to here for now. And then what we're going to do is going to take negative 1 and replace it in here. Okay. So, or if you like, you can just for now replace the letter x with the letter c, and then take negative 1 and replace it in here. And then you solve for c. And if you solve for c correctly, you will see that c is equal to plus or minus root 3. Now, minus root 3 is not in our domain. And so root 3 is the only answer, and that is option C. And that's option C. Number 29, you can skip number 29. Okay, skip number 29. Let's go on to number 30. Number 30 says an equation of the line tangent to the function at the point is, so we begin by finding the slope of the tangent line, and that's related to the derivative function, and we find the slope by plugging this into our function. So the slope is cosine of pi over 2 minus 2 sine of pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, so the slope is negative 2. We use the point provided to write an equation. So y minus y1 equals to the slope x minus x1. Distribute. And see which one most resembles that. Everything is written in standard form, so we begin by moving this to the right. Move this to the left. Seems like that's the final answer. And that matches up with B. Okay. All right. Number 31, you can also skip. So 31, skip. Number 32. Okay. Find the C value that satisfies the Rolle's theorem. So